Alright, so what we're looking at today is that we're looking at synthetic and long division. So I'm going to give you two examples of long division. I'm going to give you two examples of synthetic division. Now remember, whenever we're using these long and synthetic divisions, is to see if something is a factor of a larger polynomial. Alright, so that's what we have, and that's what we're going to look at. So the first one, we're going to use long division. So what you're going to do is you're going to rewrite the original. Okay? X to the third plus 2x squared minus 6x minus 4. And you're going to use long division. So you put your long division sign, and then you rewrite what you're dividing it by out on the outside. Now what you're looking at is you're looking at the first number here, or the first term here, and the first term of your larger polynomial. X times what gets you x cubed? That would be x squared. Okay? X times x squared is x cubed. So now you're going to multiply x cubed, or x squared, my mistake, into the original. That gets us x to the cube, x cubed minus 2x squared. And now you're going to take that whole thing and you're going to subtract it. X cubed minus x cubed is 0. 2x squared minus a negative, that means we multiply the negative in, turning it into a positive, giving us 4x squared. Drop the 6x, so it's a minus 6x. X times what gets you 4x squared? That would be a plus 4x. So you multiply 4x into both parts, that would get us 4x squared minus 8x. And now you're subtracting that second half into the first one. Gets us a 0. Negative 6x minus a negative 8x. That turns positive, giving us a 2x. Dropping the 4, or that negative 4. X times what gets you 2x? That would be a 2, which would be 2x minus 4. And then you're subtracting, getting us a 0. All right. Now, since we got a 0 at the end, that means that this is a factor of the larger polynomial, or it's a 0. So you could write this as x minus 2 times x squared plus 4x plus 2. And if you were to multiply this back into here, you'll get to the original. All right. So that's long division. Now let's look at another example. Now in this case, you see that we don't have an x cubed and we don't have an x to the squared. So what you're going to do is that you have to put placeholders in. A placeholder is a 0. So we're going to go x4 plus 0, x to the third, plus 0, x squared, plus 3x minus 8. And we're going to use long division on it. Divide it by x plus 2. All right. X plus 2. And again, we're looking at the very first terms. So x times what gets you x to the fourth? That would be x to the third. So that gets us x4 plus 2x third. And you're subtracting. That gets us a negative 2x to the third. Drop here. 0x squared. X times what gets you a negative 2x cubed? That would be a negative 2x squared. Negative 2x to the third minus 4x squared. You're subtracting again. Gets us a positive 4x squared. Again, multiply this negative in. Drop the 3x. X times what gets you 4x squared? That would be a 4x. So we have 4x squared plus 8x. Now we're subtracting. Gets us a 0. And that gets us a nice little minus 5x. X times what gets you a negative 5? That would negative 5x. That would be negative 5. Negative 5x. Oh, I had to drop this negative 8. Negative 5 times positive 2 gets us a negative 10. Subtract gets us a positive 2. This right here is our remainder. So your answer here would be x cubed minus 2x squared plus 4x minus 5, remainder 2. And we're going to talk about something called the remainder theorem that we're going to be using to help us use this remainder. Since you have a remainder, that means that this is not a perfect factor of the polynomial. All right. So if you're asking, is negative 2 a 0? You'd say no because you have a remainder. All right. That was long division. Here's synthetic division. Synthetic division, some people like because it's simpler. All you're dealing with are the coefficients. All right. So what you're going to do is you're going to make a little backwards L, and you're going to look at the coefficients. Well, the first one's 2. You see we have no x squared, so we have to put a placeholder, 0. That was for the x squared. Okay. -3, 7. In this little box, or half box, you're going to solve this right here for 0, which gets us x equals 7. And you're going to put that number into the box. All right. Now, drop the first one. So the 2 drops straight down. After that, you're taking the number in the box and multiplying it by that number to fill in the next spot. So 7 times 2 is 14. And now instead of subtracting like we did in long division, in synthetic you add. 0 plus 14, 14. And now you're going to go 7 times 14. 7 times 14, let's see, that's an 8, carry the 2, that would be 9, 98. Adding those. -3 plus 98 is a 95. Now you're going to multiply 7 times 95, that would be 5, carry the 3, that would be 63, 66. So now we have 7 plus 665, which would be about 672. All right. Now, what happens here is that we start with an x cubed here. You are going to lower the power by 1 to start. So the first one's going to be 1 less power, x squared. And these are your coefficients. And you just work down. 2x squared plus 14x plus 95. Okay? And the last number is your remainder. So a remainder of 672. So as you see here, this would be what happens if we were to factor out a x minus 7, but we have a remainder, so it doesn't factor out perfectly. All right? And again, we'll use the remainder theorem. So x minus 7 is not a factor of this polynomial. And that's synthetic division. Let's do another example. So you're going to take the coefficients, so that'll be 1, -2, 5, and -8. Solve for this, which would be x is equal to -1. That number goes right there. All right, let's change the color up. So you drop the first. -1 times 1, -1. Add -2 plus a -1, -3. -1 times 3 is 3. Adding, you add these up and you get an 8. -1 times 8 is -8. Add gets you a -16. All right. Lower the power by 1, so that would be x squared. Then it would be -3x plus 8. Remainder, -16. All right. So as we see, this one also is not a factor of the larger polynomial because we end up with a remainder. So if you don't have a remainder, it is a factor. If it's not, then it's not a factor. All right. Hope this helped.